Rewind. Hello, everybody, and welcome to Science. I hope you had a wonderful lunch and a wonderful time for math. I got a chance to look at many of your math exit tickets from this morning. A lot of them have some really great thinking. Even if you don't have an absolutely accurate answer, there's some really great thinking as we really dive into multiplying fractions for the first time. So for that first day stuff, it looks pretty good. But we're going to jump back into science. We haven't done science in a little while. We took a little bit of a break in December to work on poetry and social studies, but now we are back with science, and we are talking about answering this question: do solutions have limits? Here's what we're going to need today. You're going to need your science notebook to jot down some focus questions and to jot down some notes about our investigation today. And then here are the I cans down here. I can define solution. I can observe a mixture to determine whether or not it is a solution. I can define saturated solution. That's new to us today. And I can use tools to determine how much solute has dissolved in water. So, here we are. Here are the three focus questions that we're going to need today. I'll move my big head out of the way so you can see them in just a second. But I also want to focus on our word wall right over there and reminding ourselves of these two words here, solute and solvent. Okay? Solute being the substance in a solution that's being dissolved, and solute being the amount or the thing that solute, the substance in a solution that is being dissolved, solvent, the substance in a solution that is being dissolved into. In this case, we're going to again use our old standby of salt and water. Okay? Back in our previous investigations, we already looked at what happens when you mix salt and water, and that salt seems to disappear. It appears to disappear, although it actually doesn't. It's just incorporating fully and creating a solution. And it can't be separated out by a filter or a screen like our other mixtures could, like our gravel or our diatomaceous earth. Okay? It can be separated back out by using evaporation. Okay? Here's our salt crystals from our previous investigation. We took our saltwater solution, we put a sample of it in our evaporation dish and let the water evaporate out, and we were left with these very nice little square-looking salt crystals behind here. Okay? But today we want to know, is there a limit to how much salt will dissolve in water? Or the more general question being, is there a limit to the amount of solute that will dissolve in a solvent? Okay, this can apply where it started to develop our thinking around any solution, not just salt and water. Okay, the second question being, how will we know if a limit has been reached? What evidence are we going to see or experience that let us know that our solvent, our water in this case, it can't dissolve any more salt? What are we going to see? Is it going to turn green? Is it going to explode? Is it going to melt the bottom of the container? Or is something else going to happen? Okay? And then the last one, if a limit is reached, how can we measure how much solute has dissolved? Okay, so we're going to be trying to answer these three questions today. So go ahead, take a minute, jot those down, now that I have moved my big fat head out of the way. Question number one, is there a limit to the amount of solute that will dissolve in a solvent? Number two, how will we know if a limit has been reached? And number three, if a limit is reached, how can we measure how much solute has dissolved? Those are our 3 focus questions of the day. Now, if we were in the classroom, what we would be doing, and I'm actually going to, so I can see everybody, I'm going to move our word wall out of the way here. There we go. So I can stand here. You can still see the questions and my face at the same time. If we were in the classroom, what we would do, here's our procedure. Well, we'd kind of think about our procedure and have a discussion about how we might do it, and then we would come to this conclusion of we're going to take some water. This is plain tap water. Okay, this is 50 milliliters of water, which has a mass of 50 grams. Okay, if you remember from previous investigations, volume in milliliters is how much space something takes up. Mass is how much matter something has. Okay, and there's also density, which is like how much mass is packed into volume. So that's why mass and volume measure 2 different things, really. Okay, with water, it happens to be that 1 milliliter of water on Earth equals 1 gram of mass. So our 50 milliliters of water equal 50 grams of mass. Then what we would do is we would take some salt. Here's our salt. We'd put in a scoop. In this case, it's 5 milliliters, though 5 milliliters of salt does not equal 5 grams because they don't have the same density. And then we would stir, 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 stir. In previous investigations, it's completely disappeared because we've dissolved that salt in water. Okay? In the interest of time, because it does take a minute or 2 for me to sit here and stir this, and because you don't want to watch me stir water for anywhere between 5 and 10 minutes, it doesn't make for the most riveting video. I've already done it. Okay, so we're going to observe. Here's our control. 0 scoops. Let me tilt this down. There's our water. If you can, there we go. There's our control. No salt in this water. Okay. Next, we're going to go with 1 scoop of salt. What do you notice? What do you see? What do you notice? Trying to tilt it as much as I can without spilling salt water on my laptop, because that would be unfortunate. Any change here? I can even kind of do one of these, and you can look at it from below. That's actually helpful. Let's compare it to our control. So here's our control again from below. And here's our 1 scoop of salt. You see any real change? Not really. Maybe the 1 scoop is slightly cloudier because it's got a little bit of salt in there, but no real change. Nothing on the bottom, hasn't changed colors, hasn't exploded. Okay, let's look at 2 scoops of salt. If we were doing this in the classroom, you'd start with 1 scoop, stir, 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 observe, observe, observe. If we don't think we've reached a limit, put in another scoop and kind of keep going until we've reached a limit. So here's 2 scoops. Zoop. There's 2. Still pretty clear, huh? Let's compare it to our control. So here's our control. 0 salt in this one. And here's 2 scoops. Pretty similar, pretty no change, huh? Maybe even a little bit cloudier, but again, it could be, you know, like we said in the chat, could be the cup, could be a little different. I think it is slightly cloudier to my eyes, just again, because there is a little bit of salt in there, but no major changes. Okay, so 2 scoops, still haven't really reached a limit here. Let's take a look at 3 scoops. 3 scoops of salt. What do you see? What do you notice? And let's compare it to our control. Here's 0, and here's 3. zoom in close. What do you see there? See some little things moving along the bottom here? We've got, at 3 scoops, we've got some undissolved salt there at the bottom. In terms of solutions, they still look pretty similar. They haven't turned green or anything. But with 3 scoops, you can certainly see some undissolved, little bit of undissolved salt going on in there. Okay? Now, I also did one with 4 scoops. So put your hypothesis and your inference caps on here. If 3 scoops had just a tiny little bit of undissolved salt in there, what do we think 4 scoops is going to look like? Think, think, think. Think, think, think. Let's check. So again, here's our control. Let me tilt this up again so you can see. Zoop. Here's the ceiling. Here's our control again. And then here's 4 scoops of salt. What do you notice about this sample with 4 of these scoops? So a full-on 20 milliliters, probably a little bit more because I didn't flatten it out. But a full-on 20 milliliters of salt, and we've got a lot of undissolved salt. Even after stirring it for, a number of minutes. Okay, it's not like I just left this one. I stirred all of them for roughly the same amount of time. So we've stopped, our salt has stopped dissolving, which means that answer to that first question, is there a limit to the amount of solute that will dissolve in a solvent? In the case of salt and water, yes, there is a limit. Okay, if there wasn't a limit, then all of our samples, even if I put 20 scoops of salt in, would look exactly the same, because it would just keep on dissolving and keep on dissolving and keep on dissolving. I see in the chat, I see how much is 1 scoop. I used you can't really see it because it's yellow on yellow, but a 5 milliliter scoop. And I did not exactly measure, I did kind of a heaping scoop, so it's probably more like 6 or 7 milliliters per scoop. Okay, and then question 2, go ahead and think about that one. How do we know, or how did we know, what did we observe, what evidence was there that a limit has been reached? What did we see, what did we observe that led us to believe that a limit as to the amount of solute that will dissolve in a solvent has been reached? Okay, and if you have an answer for number 3, or a possible method for number 3, if a limit is reached, how can we measure how much solute is dissolved? Go ahead and drop that in the chat, because we are going to explore that in a second. So how will we know if a limit has been reached? What did we observe? What evidence did we see? Okay, I see a couple answers in the chat already. Because the salt stopped dissolving. Yeah, it collected at the bottom, right? That kind of shows us that even after mixing, if all that salt's still collecting now, that means that our solvent, it can't take in any more solute, right? We can measure how much is dissolved by tasting it. We certainly could. We did that with our concentration of orange soda, right? However, again, I'm kind of not in the business of trying different concentrations of salt water. I think there's a little bit more of an accurate way. You might try scooping it out. We could, but we might lose some water in the process and kind of mess with our results a little bit. Ava's not sure if straining would work. Matthias says we need a really small hole size strainer. Can I interest you in a full-on filter? Let's take a journey, shall we? Over here, ta-da! And here we have, well, one, we have our balance with 50 grams already loaded in there, so we can measure at the end. And then we have our coffee filter, right? This is what got our diatomaceous earth out of the water. And so, if we're thinking that all of this salt at the bottom of our solution is not dissolved, then the thinking is it should filter out with this filter. So let's pour this in carefully and give it a try. And I am noticing that most of the undissolved salt is actually remaining in the cup because of some surface tension, and it's kind of stuck on the bottom there. But I am seeing that even if I knock all this undissolved salt into our filter here, that it's certainly not going through to the bottom of the cup. Let's give it a little squeeze, make sure we're not leaving any water in there. Okay, and now, if you can see our filter here, we've got a bunch of undissolved salt in there, and that extra salt was caught by the filter. So now let's answer our third question. Now that we've filtered out, oh, there's my thumb. Now that we've filtered out any undissolved salt, what this should be is 50 milliliters of concentrated or saturated salt solution. When we say that something is, a solution is saturated, what we mean is it can't take in any more of that solute. Okay, it's got as much solute as it can take in, and it is kind of as concentrated as it can be. So let's see now how many grams of salt dissolved in our fully saturated salt solution. So remember, we've already got 50 grams here. This is balancing out the weight of the water. If we put in our control, our 0 scoops, we can see that our line there goes straight to balanced in the middle because we've got 50 grams and 50 milliliters. So let's see this is our saturated solution. Let's find out how many grams actually dissolved. Shall we start with, well, let's think about this. We put in 4 scoops, that's 20 milliliters. It's sunk to the bottom, so salt is heavier than water. So 20 milliliters has got to weigh more than 20 grams. So around 20 might be our limit, but let's start with 5, let's say. We're going to put a 5 in first. It's more than 5. Should we try another 5? That didn't really move, so I think we're going to try another 5. We're going to go 10 grams. Interesting. Didn't really move either. Let's go another 5. If it's too much, we'll take that 5 back out and we'll go to 1. We've got movement now. Another 5 maybe? Or up to 20 grams of dissolved salt? Let's see. Oh, it's close. It's close. Look at that. Let's add a 1. 21 grams. Does that arrow there look lined up with the little bar in the middle? Almost. Let's go one more. 22. And finally, we have reached just about, maybe even, I think 23 will take us past. Make it too heavy, but let's see. Yeah, you see how 23 took it too far behind. So we could even say maybe if we wanted to 22.5 grams. somewhere between 22 and 22.5 grams of salt. That's the limit, the most salt that can be dissolved in 50 milliliters of water. 22 grams of salt. Pretty amazing. Okay, so just to recap, and let's take us back over to our focus questions here before we go. So let's try not to spill salt water all over everything. There we are. So we've got going to go this way. Is there a limit to the amount of solute that will dissolve in a solvent? Our answer is yes. How will we know if a limit has been reached? There will be undissolved salt at the bottom of the container. Or there will be undissolved solute, right? If we're not using salt, there will be undissolved solute. And maybe it's not at the bottom. Maybe it's less dense than water, so maybe it'll float. So maybe we'll say undissolved salt mixed with the solution. Remember, we can say that it's mixed because it can be removed by a filter, as we saw there. And then if a limit is reached, how can we measure how much solute has been dissolved? Filter the mixture. Then find the mass. And actually what we're doing there is we're comparing the mass of our saturated solution to the mass of our control, the mass of just the water, right? So if we had 22.5 grams of salt, and 50 grams of water, what's the total weight of our saturated solution? 22.5 plus 50. Okay. Exit ticket today is kind of pretty much what we just went over here. So if you watch to the end of this video, the exit ticket should be pretty easy for you. If you didn't watch to the end of this video, or you didn't watch it at all, you're going to be completely lost. Ha 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 ha! That's my check to see who's actually watching these and who is not. Sneaky teacher tricks. I know. So mean. So mean. Thank you for tuning in, everybody. Tacos, as a reminder, writing groups A and B, we are meeting shortly in the Zoom room to talk about on the question of race. Non-tacos, thank you for coming, and we will see you soon. Next science lesson will be Friday at 12:30. We're going to be looking at is this limit 22.5 grams of salt in 50 grams of water, or in 50 milliliters of water? Is it going to be 22.5 grams of any solute? Or will the saturation limit change depending on what is being dissolved? Marinate on that until Friday. Otherwise, have a great rest of the day. I'll see you in writing group, and I will see you at game time at the end of the day if you so choose. And you've got makerspace in the middle. Go to all of them. Thank you. Love you. Bye.